Let's revise a little bit on Bohr's atomic model. In order for an electron to jump from lower energy level to higher energy level, it needs to absorb energy. And when the electron is falling from higher energy level to lower energy level, it will release energy. I'm going to use an analogy of a person weighing its body to see how much mass had changed during a period of time. In scenario number 1, let's say this person weighted initially 50 kgs. After some time, his weight have become 58 kgs. So if we want to know how much have been changed, we can deduct his initial weight from his final weight. This will give us a total weight gain of 8 kgs. In scenario number 2, this person initially weighted 60 kgs. After some time, his weight becomes 55 kgs. Again, to know how much is changed, we minus the final weight with his initial weight. This brings total weight loss of 5 kgs. Notice that the negative sign here means that the mass is decreasing. The same concept applies to the change of energy in electron. If we want to measure how much energy is being absorbed or released, we need to compare its initial energy with its final energy. For example, in this case, the electron is moving from n equals to 1 to n equals to 3. So to calculate its energy change, we deduct energy at n equals to 1 from energy at n equals to 3. Using Bohr's formula to calculate the energy in each orbit that we have learned earlier, we can derive a new set of equations to calculate the energy change. Since delta E, or energy change, is equals to energy at final state minus energy at initial state, we then substitute energy at each level with Bohr's formula, taking RH outside of the bracket and pull the other factor together. And finally, rearrange the equation so the positive term comes first. Now let's come back to our earlier example. Let's use this new formula to calculate the electron's energy change. Since n initial is 1 and n final is 3, we substitute n initial as 1 and n final as 3 in the formula. The energy change is 1.94 times 10 to the power of negative 18 joule. Since we get a positive value as an answer, this means that energy is being absorbed. Let's try another example. This time, the electron is falling from n equals to 3 to n equals to 2. To calculate its energy change, we should deduct energy at level 2 from energy at level 3. By using the formula, we substitute 3 and 2 as n initial and n final respectively. This time, the energy change is negative 2.92 times 10 to the power of negative 19 joule. Note that the negative sign indicates that energy is being released. It is important for us to pay attention to the correct n initial and n final that is being substituted to the formula, because not only we are interested in knowing the value of the energy change, but we also concerned on whether the energy is absorbed or released. Just like it is important for us to not only know the mass change when we weight our body, but also we want to know whether the weight is gained or lost.